Okie dokie. So this problem is a type 1 with an angle. So this problem says you have an object launched at a velocity of 20 meters per second in a direction that makes an angle 25 degrees upward with the horizontal from an initial height of 75 meters. What's the time it takes to reach the peak? So tons of information. So to set up our chart for x and y. Okay, so in the x direction, what we can have is delta x. We'll have the initial x, we'll have the final x, we will have acceleration in the x, and we'll have time in the x. In the y, since it is one with an angle, we're going to have the original height of the cliff or whatever it is. We're going to have the change from cliff to its maximum height. We're going to have maximum height down to the ground. We're going to have the time it takes to go up, time it takes to go down, acceleration, which is always gravity, the initial x, the initial y, and the final y. Right now, our total information that we already have, which is both x and y, is that the initial is 20 meters per second, and the angle provided is 25 degrees. Right, and the problem also tells us that we know the initial height of 75 meters, so that means our delta y cliff is negative 75 meters. So we have our cliff, so this is 75, there's our object, there's our initial of 20, that's our angle of 25, projectile is going to go up, and then come down, something like that. Alright, so that's the shape of the object. So what's the time it takes to reach the peak? Right, so we want to figure out how much time it takes to go from where it starts to where it hits the maximum height. And we know that the velocity at the maximum height, which is the peak, in the y direction is always 0. So that's going to help us to solve. So that's good to know. So what we need to do before we can even solve is we have the total v initial, but we don't even care about the total v initial. So we need to have our components first. So our components, if we make a component triangle, like so, we have our total, which is 20. We're going to have our angle 25 degrees. So we're going to have Vy over here and Vx over here. So to get each piece, we have to use a trig function. Now Vx is touching the angle, and so is the hypotenuse. So to find Vx, we're going to do V initial multiplied by the cosine of theta. So V initial is 20 times cosine of 25. And you have to be in degrees. So if you are in degrees, you will get an answer of 1812 or 1813. So I'm just going to stick with 1812. So that's V initial in the x direction. So we can throw that over in our table. Right? And then V initial in the y, since it's on the opposite side, the y is going to be V initial multiplied by the sine of theta. So that's going to be 20 multiplied by the sine of 25, which is going to be 8.45 meters per second. That's our V initial y. Alright, so that's information that we have so far. Now, question says, what's the time it takes to go to the top? So since we're talking about the first interval, we can ignore the second half. So if we want to find time, we want to find an equation that has enough information that we already know. So now we know V initial in the y direction is 8.45. We know V final in this interval in the y direction is 0. And we know acceleration is gravity. So we can use V final y equals V initial y plus gravity times time. And that's going to be time up. So that's going to be 0 is equal to 8.45 plus gravity times time up. So we rearrange so that we can solve. So we end up with a time up of 0.845 seconds. So it's going to take this object 0.845 seconds to reach the top. Now because this projectile goes up and then falls below the original starting height, the time down is not going to be equal to time up. So when we get there, we're going to have to actually solve for it. So that time up is 0.845.